All right. You will want to have your formula sheet nearby. Of course, we looked at and learned the properties of logarithms, and so those are going to come into play today. And then we are also going to kick in and apply some derivative rules, and some of them can get pretty detailed and involved. And so I'm going to be referring back and forth to those properties and derivative rules. All right. So we are in 4.3, which is the derivative of logarithmic and exponential functions. All right. So the derivative of the natural log of x is equal to 1 over x. And so you need to make sure that you get that memorized, okay? Just 1 over x. So let me give you an example of where this comes into play. So you have the function x to the 4th natural log of x. All right, so the first thing that you need to recognize on this is that these two are being multiplied, which means we are going to apply the product rule, which we learned back in a previous chapter that doesn't go away. So if you recall, we can call this 1 and we can call this 2. And so it is 1d2 plus 2d1. So 1 times the derivative of 2 plus 2 times the derivative of 1. So those things don't go away, they just continue to build on each other. All right, so in taking the derivative, we do 1 times the derivative of 2, and the derivative of 2 is 1 over x, plus 2, natural log of x, times the derivative of 1. And so that would be times 4x cubed. So then it's just a matter of cleaning it up a little bit. Of course, this is x to the 4th over 1. And so an x is going to cancel and this will become x cubed. So we would get x cubed plus, and then you typically put this in the front of a natural log. So we would write this as 4x cubed times the natural log of x. Now, this right here is sufficient. If this were a question on WebAssign, if you plug that in, you're going to get the correct answer. Some of you with a strong algebra background might look at that and say, okay, we have two terms and they share the greatest common factor of x cubed. So you could factor x cubed out of here, which would leave you with 1, and factor x cubed out of this, and you'd be left with, what am I factoring out? X cubed. So you would be left with 4 natural log of x. So either way that you substituted it in, you'd be perfectly fine, okay? All right. Next derivative. The derivative of a natural log of a function is equal to the derivative of this function over the function, okay? We could actually apply this rule up here let me show you something. So we had, if you're going to take the derivative of the natural log of x, and you're going to follow this rule here, then this right here is your f of x, okay? So we would take the derivative of our f of x, and the derivative of x is 1 over f of x, and f of x is just x. So that's in essence how they get there. Okay, so we actually applied this rule. It's just that this one is such a common one, then it's recommended, hey, just go ahead and memorize that. Okay, all right, so let me give you an example that is a little bit more elaborate than that, applying this derivative rule. All right, so y equals the natural log of 2x squared minus 6x plus 1. So if you're asked to find the derivative, all right, so I want to look at this, and I need to establish that, okay, this trinomial is considered my f of x. So here, I'm going to bring this down so I have a little bit more room for the derivative. Okay, so the rule tells me I'm going to have a numerator and a denominator, and in the numerator, I take the derivative of this function. So I'm going to take the derivative of this, applying our derivative properties. So that would be 4x minus 6, and then of course the derivative of 1 is 0. And then the denominator is just that function, 2x squared minus 6x plus 1. And that would be my answer. Okay. All right, let me give you another example. We have the function f of x is equal to the natural log of 3x minus 3, all of that raised to the 4th power. Now, there's actually two approaches to this. I'm going to show you both approach. So the first approach is what we just learned. This would be your f of x. But where you need to be careful is, since this exponent is on the outside of the parentheses, you are going to have to apply the chain rule when taking the derivative. So that's why it's important that you have all of those well established, what we learned earlier in the semester. Okay. All right. So taking the derivative. So when I'm taking the derivative of a natural log, and if you'll see, this is right here on your formula sheet. So it tells me, since I have a natural log and a function, then I take the function's first derivative, and that's what goes in the numerator. Okay, so in my numerator, when I take this derivative, I bring the 4 out front. So I have 4 times 3x minus 3. 4 minus 1 is cubed. And then you have to remember, don't forget to take the derivative of the junk inside. All right, so when you take the derivative of what's inside, that would just be 3. So times 3. So we've taken the first derivative. Now the denominator will just be rewriting the function. Now, we've shown taking the derivative. Now we need to clean it up a little bit. So what I want you to notice is that this binomial and this binomial are the same. There's 3 on top and 4 on bottom. So we can get rid of all 3 of them on top. We can get rid of 3 of these on bottom. So we're still left with 1. So then I look at the numerator, and all I'm left with is 4 times 3, which is 12. And in the denominator, I have 3x minus 3. And here again, this is sufficient. I may have some students that look at the denominator and say, hey, there's a greatest common factor of 3. So absolutely, you can factor out a 3 and then simplify that and get 4 over x minus 1. Either is fine with me. WebAssign will take this as a fully correct answer. Okay, so you can choose what you want to do. Now, when I wrote out this function right here, I told you I'm going to show you 2 ways to approach it. So I'm going to rewrite the function again, just so this is the same function. And I'm going to show you the second approach. If you will go back to these properties right here, well, actually the natural log ones, if you'll go to these properties right here, so notice we had that exponent on the 4. So before we ever start taking the derivative, we can rewrite that function by bringing that exponent out front and then just writing what is left. So what I mean is it's still its original function. So I'm not starting to take the derivative yet. So what I can do is rewrite that by bringing that 4 out front, and then I would have natural log of 3x minus 3. Then what we can do is say, okay, now I'm going to take the first derivative. This is just a constant that stays there. And then now what we're going to do is take the derivative of this, which says your numerator will be the derivative of f of x. So I'm going to take the derivative of 3x minus 3, which would just be 3 over the function 3x minus 3. And of course, we know 4 is the same thing as 4 over 1. So my numerator would be 4 times 3, which is 12. My denominator is 3x minus 3. So as you will see, regardless of which method you use, we get the same correct answer. Okay? All right. So a completely different example, a different function. Y equals 2x minus 7, natural log of 2x minus 7. All right, so in this, again, you're going to have to be careful and recognize that I'm taking 2x minus 7 times the natural log of 2x minus 7. So here we have 1, 2, and you're going to have to apply the product rule, 1d2 plus 2d1. All right, so 1 times the derivative of 2. Now we have the natural log, so I need to put in the numerator the derivative of this 2x minus 7, which is just 2, over that 2x minus 7 plus 2, natural log of 2x minus 7, times the derivative of 1, and the derivative of this is 2. Now, if you'll look here, this is like over 1, so this cancels that because they're the exact same thing. So I'm left with the whole number 2, plus I can't do any simplifying or reducing here, but I am going to put this number out front, 2 natural log of 2x minus 7. And that would be my answer. Okay, all right. So there's some that deal with the natural logs. Now we need to look at when we are dealing with E. So when you're taking the derivative of E to the x, it is just equal to e to the x. Okay. Now, if you have something other than x up here, and you will, all right, here's what it's equal to. It's equal to this, e to the f of x times the derivative of that exponent. All right. So if we actually applied this rule up here, let me show you. It tells me to just rewrite this e to its exponent times the derivative of the exponent. What is the derivative of x? 1. And e to the x times 1 is just e to the x. So it's just one of those kind of like the one that was just the natural log of x is 1 over x, the natural log, or I'm sorry, the derivative of e to the x is just e to the x. Okay. All right. Well, let's get our feet wet with some examples on applying this right here. So y equals 3e to the 2x. Now, yes, this is 3 times, but be careful. You don't have to use the product rule because 3 is a constant. So if you go back when we're doing the derivative, you just leave that 3 alone. All right, so now we're going to take the derivative of this. So the derivative says just rewrite it, then take the derivative of the exponent, and the derivative of 2x is just 2. And then, of course, I'm always going to clean that up. 3 times 2 is 6, e to the 2x. One that kind of throws some people sometimes. So I just want you to point out this one and where to be careful. So we have e to the 8. All right. So in taking its derivative, it tells me to just leave it alone times the derivative of the exponent. Well, what's the derivative of a constant? Hopefully you remember, it is 0, and 0 times anything is just 0. Now, here's where I want to tell you to be careful. Sometimes in students' haste, we've done x to the 8th, and when you take its derivative, it is 8x to the 7th. Okay? Here's where I don't want you to get in a hurry. Here's where I want you to be careful. Do not apply what we do here to this one. This derivative is not 8e to the 7th. So be careful. That is incorrect. When your base is an e, then you are going to have to apply this rule in order to take its derivative. So I just wanted to kind of point that out for you to be careful. All right, let's look at some more in-depth examples. All right, f of x is equal to e to the x over x squared. E to the x over x squared. Okay, I do want to remind you that the derivative of e to the x is just e to the x. Okay, so that's going to come into play. Now, we've already dealt with the product rule, 1d2 plus 2d1, okay? But this is going to be your quotient rule. And I typically see students have a little bit more time or difficult time with the quotient rule. So remember, the denominator is low, the numerator is high, and the rule tells us low d high minus high d low all over low squared. okay? So low D high minus high D low all over low squared. All right, so we're going to take the derivative, applying the quotient rule. So we start out with low, which is x squared, times the derivative of high. And if we go back to the previous page of our notes, we know the derivative of e to the x, it has to only be an x. If there was a 7 there, I couldn't use that rule. If there was an 2x, I couldn't use that rule. Just e to the x is e to the x minus high times the derivative of low. So I look at the denominator, its derivative would be 2x to the first, all of that low squared. All right, so in cleaning that up, I have x squared e to the x minus, I'm going to put the 2x in front, e to the x, all over x to the fourth. Now, you could, in the numerator, factor out a GCF of x and then reduce that with the denominator, but it's not required. You don't have to in WebAssign, so it would count both as correct. So here's the derivative. Sometimes either me on a test or in your assignments in WebAssign, it's going to say, okay, find the derivative, and then it's going to ask you to take that derivative and find the value for a particular number. So for this one, everywhere there's an x, I'm going to put 1. So I would get 1 squared times e to the first minus 2 times 1 e to the first all over 1 to the fourth. So when I go to simplify that, I know that's 1 squared times e to the first is just e. And then I have 2 times 1 is 2, e to the first is just e. So this would be minus 2e all over 1. So I have 1e minus 2e is negative 1e. Okay. All right, f of x is equal to the natural log of x to the 6th plus 7 minus 9e to the x over 3. Okay, that's a little interesting. Minus 2x. Should have separated that a little bit more, but we'll make it work. We'll do this. All right. So we're going to take the derivative. So I have to take the derivative of this minus the derivative of this minus the derivative of this. Okay, so it's going to take several steps, and to be very careful when we're doing this. And I'm going to refer back to the formula sheet. Okay. This is the natural log. So we're going to take its derivative. So I'm going to follow this right here. So I'm going to take f of x, derivative in the numerator, rewrite the function and put it in the denominator. So my f of x is x to the 6th plus 7. So the numerator is that derivative, which would be 6x to the 5th. And the denominator is x to the 6th plus 7. All right, minus, now we're going to look at taking the derivative of this, and that's x over 3 is your exponent. Okay, now the coefficient of 9, we just leave that alone. So we would have 9 times. So now we're going to apply this derivative rule. So just rewrite it and then take the derivative of the exponent. So we will rewrite it. Now I'm going to have to take the derivative of the exponent, x over 3. Okay, quotient rule here. So we have to go low, d high. So low is your denominator. Derivative of high, so the derivative of x is 1, minus high, d low. The derivative of 3 is 0. Well, that's kind of sweet. X times 0, that's just going to be 0. All over the denominator, or low, squared. Minus, and now the derivative of this is just 2. So where we're going to have to do some cleanup is right there in the middle. So I can't clean this up really. All right, so in looking at this, that goes away. This 3 squared is the same thing as 9, okay? So what I want you to see, I'm going to go ahead and write it in one more step. Some of y'all might already see it, but that's okay. I'm going to write 9e to the x over 3 times, and I'm left with 3 in the numerator, 9 in the denominator, and then we still have this minus 2. So I can still clean this up a little bit, because you can think of 9 as 9 over 1. So what happens is that 9 cancels with that 9. So what we actually have is 6x to the 5th over x to the 6th plus 7 minus, this is on top. I'm just going to move it to the front. So we have 3e to the x over 3 minus 2. So that middle part definitely took us a little bit of work. And you're going to have some similar to that in your homeworks. And so be prepared to handle that possibly on a test. Okay. Now, previously in the semester, we learned how to find the equation for the tangent line. And we have not done this in a while. So I definitely wanted to put one of these in my lecture so we can just kind of have a shake the cobwebs out of our head and remember how to do it. All right, anytime you see tangent line, now we want to ultimately have a line that's in the form y equals mx plus b. When you see tangent line, so you're finding the equation for the tangent line, then that tells me, oh my goodness, I need to remember I'm going to have to take the first derivative. All right, so here's kind of the steps that we did. So we have to generate, so we want to use the point generator, which we know comes from the original function. We need to use the slope generator, which that comes from the first derivative. And then we have to use the point slope form of y minus y1 equals m times x minus x1. So this point generator is what's going to supply x1 and y1 for you, and the slope generator is what is going to provide your slope or your m. Okay, all right, so we are given the function x natural log of x minus 1 at x equals 2, and what I'm asking you to find is the equation of the tangent line. So we want the equation of the tangent line at x equals 2 for this function. Okay, so we're going to do each one of these. All right, so let's first look to find a point. So we use the original function. So we're going to take this original function, when x is 2. So I would have 2 times the natural log of 2 minus 1. So you can go to your calculator. So 2 times the natural log of, and of course you can put 2 minus 1 in there, or you can do that in your head, whatever you want to do. Hey, that's 0. You know why it's 0? Let me show you. 2 times the natural log of 1. The natural log of 1 is equal to 0. So this right here is 0. 2 times 0 is 0. So what this tells me right here is it gives me the point input 2, output 0. So this is going to be my x1, y1. Now the slope generator. Well, I need to find the first derivative. So we're going to have to take this function and we're going to have to apply the product rule to get its derivative. All right, so 1 times the derivative of, all right, so the numerator is the derivative of x minus 1, which is just 1, over x minus 1, plus 2, natural log of x minus 1, times the derivative of 1, and the derivative of x is just 1. So we have x over x minus 1 plus the natural log of x minus 1. All right, so here is how I find my slope. So to find the slope, we're going to do the first derivative for the point 2. So we would have 2 over 2 minus 1 plus the natural log of 2 minus 1. Of course, you can put all of that into your calculator and find the slope. I know 2 minus 1 is 1, 2 over 1 is 2, plus the natural log of 2 minus 1 is 1. So this is the natural log of 1, which we just talked about, y'all. This is 0. So 2 plus 0 is 2. So this gives me that my slope is 2. So now I have a point. Now I have a slope. So now we are going to put that into the point slope form. And then solve for y. So it's y minus y1 equals slope, x minus x1. So of course, y minus 0 is y equals 2x minus 4. So all of that work, this is what my answer would be, the tangent line, the equation of the tangent line. All right, we're going to do an application problem, and then that will complete it for this section. After T weeks, of practice, a pole vaulter, my nephew did the pole vault, will reach height of, and then we are given the function h of t equals 15 minus e to the negative 0.1 t. So t represents weeks. So 1 week, you put it in the function and it tells you what height will be reached. Okay, but what you're going to be asked to do is to find the rate of increase in the height of the vault at week 0 and week 6. All right, here's what should jump out to you right here. Rate of increase. Rate of increase tells you, oh my goodness, I need to take the first derivative of my function. Once I do that, then I can plug in 0 and 6 for my t. But because it says rate of increase, that tells me I have to find the derivative. So we're going to find the derivative of this. So the derivative of 15 we know is 0. Here, all right, so it's minus. So it's an e, so rewrite it. Times, then take the derivative of the exponent. So the t has an exponent of 1. 1 times negative 0.01 is negative 0.1. And then, of course, that would be t to the 0, so it goes away. All right, so just to clean this up, I don't need the 0 here. I am going to move this to the front, and I have this is negative and this is negative. So, of course, oh, I wrote this down wrong. This is 11. Okay, so this is 15 minus 11 e to this. Okay, so sorry about my mistake. It's an easy fix. Why? Because the derivative of this is still 0. When you have the number out front, it just stays put, and then we leave the e alone and then take a derivative of its exponent. So we're good. All right, so then in cleaning it up, the 0 goes away, and I'm going to take negative 11 times negative 0.1, which is positive 1.1, and then we have e to the negative 0.1 t. Sorry about that error. I'm thankful that I caught it. All right, so here is my derivative. So rate of increase, we took the derivative. So now we want to know when t is equal to 0 and t is equal to 6. So at that first derivative, I'm going to substitute in 0. Negative 0.1 times 0 is 0. Anything to the 0 power is 1. So you just get 1.1 feet. And then we're going to do the same thing. And now we're going to put a 6 in for this. So I go to my calculator, 1.1 times 1.1 times second natural log gives me the e, and then the exponent negative 0.1 times 6, and I get approximately 0.604. This represents your rate of increase. Now, if you wanted just to know, hey, how high are you jumping at 0 and 6, you come back and use the original function. So how high are you jumping up here, rate of increase down here.